This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's episode 726, and this week we welcome Stephen Cooper and Gavin Macgregor-Skinner for a show on disinfection technologies. What lessons did we learn during COVID, and what should restorers and others watch for when purchasing and using disinfection technologies? Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget, after the show, you can continue the discussion on afterthoughts.iaqradio.com. IAQ Radio Association sponsors are AIHA, the American Industrial Hygiene Association, at aiha.org. IICRC, the Institute for Inspection, Cleaning, and Restoration Certification, at iicrc.org. The Restoration Industry Association, RIA, at restorationindustry.org. The Environmental Information Association, EIA, at eia-usa.org. IAQ Radio industry sponsors are Particles Plus at particlesplus.com, ByoPlanet at byoplanet.com, Actionable Insights at getinsights.org.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick at cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm happy to report that Doug Conan, Aerotech Environmental in Dayton, Ohio, was the first person to identify middle school science teacher as May Dooley's occupation prior to her entering the field of building and indoor environmental investigation and consulting. Here's this week's IAQ Radio Trivia question. Who is the holder of U.S. patent number 2247963, 2247963? Back to you, Joe.
All right. Gavin Macgregor-Skinner is the Senior Director at ISSA, the Worldwide Cleaning Trade Association. He has more than 30 years of technical experience in responding to infectious disease outbreaks and emergency management. He's also an associate professor in the Department of Public Health Sciences at Penn State College of Medicine and teaches 3 15-week graduate courses on public health. He has appeared on CNN, Fox News, BBC, and many other news outlets to share his expertise on high consequence pathogens.
Stephen Cooper is an engineer with technical specialty in the research and development of water-based electrostatic spraying systems. He's developed innovative core technology and commercial products related to air-atomizing induction-charging, known as AAIC spray systems. Mr. Cooper is an engineer, scientist, as well as an entrepreneur. He is co-founder of ByoPlanet, Salt LLC, and has been involved in establishing several other successful companies. Mr. Cooper received his undergrad and master's degrees from the University of Georgia and has been continuously involved with Applied Electrostatics Laboratory for over 3 decades at the University of Georgia. Welcome, Joe.
All right, gentlemen, great to have you. We talked earlier this week. It was a very interesting discussion. And, when we covered a lot, but before we go into the electrostatic technology, I just want to get your impressions on lessons learned during the COVID pandemic. There was a lot of disinfection going on during that period. And we're curious as to what we learned, at least what you as experts learned during that period. Let's start with you, Gavin.
I think the big lesson for me was what gets measured gets done. The fact that the many conversations I have with both federal and state government that still, and this is a very touchy subject with me, that I'm, advocating for all of the clean industry. We are not an unskilled workforce. And I was told that just recently at the Department of Labor meeting last week. Oh, Gavin, you represent an unskilled workforce. And I went, no, we based cleaning on science, evidence, chemistry, industry best practices. So I would go back to say that even what we experienced through COVID, our industry is essential. Many people don't understand how we clean for health and safety, not just for appearance and smell, but more importantly, the science and the evidence that backs what we do, and the necessary skills that our workers need to understand the chemistry of cleaning, as well as how to clean safely and with great effectiveness. And that's, they only look to us when things go really bad, like when we go to critical failure, or that wasn't cleaned properly enough. And there's not enough recognition for our industry as essential frontline workers.
Steve, let's ask you the same question.
Well, it was a interesting time in the spraying industry. I mean, that's what I do is work with the spraying side of things. And what I saw was a lot of people jumping to look for a silver bullet. People want to keep their businesses open. They want to make sure that customers feel comfortable coming into whatever it might be, a car dealership, a salon. And so they went and bought spray equipment, and not really ever having disinfected before, thought they were looking for the silver bullet, and they had it and everything was fine. And just to echo what Gavin said, it's not that at all. This is a skilled business. We have to have the right equipment. We have to have the right chemistries picked for the right pathogens, and we have to have the right training to do the job right. And I think that during the COVID time, at least in the sort of retail industry or people who hadn't disinfected before, there's a lot of people just going to Amazon, buying something and saying, hey, I'm doing a disinfecting job. And so that opened my eyes. There's a huge opportunity for us as leaders of industry to start educating people on the correct choice of equipment, correct choice of chemistry, and do some really good training about how to disinfect and all that involves. It is not an unskilled practice. But the whole world was trying to spray something, and it was crazy. It was crazy.
They were also looking for the cheapest way out too, I think.
Looking for the cheapest way out. But there was a group that I got involved in that Gavin knows really well through the ISSA. It's the GBAC, Global Biorisk Advisory Council. And they guided me a lot. They said, hey, Steve, here's the things that we need to see, and then we can help guide people on the right practices. And so we work with them as a manufacturer of equipment and also as a producer of some chemistries in order to register our products with that group. And I think that helps the consumer then start to understand and make decisions. But they also have very good training modules. So, and it's open to all. I mean, you want to get trained in several different levels, basic levels to all the way to high skilled levels. That's an example of an organization that can help do that. And so that got accelerated during COVID, that whole idea of we need training. How do we get it out there? And there's some good response to that, and some very fast response to that.
I want to turn it over to Cliff in a second here, but before I do, I want to mention a book. Gavin, I have a feeling you're very familiar with this, Cleaning for Health, which for some reason what you said reminded me of that book. Maybe you could talk to people about it, if that had any impact on you, if you're even familiar with it.
Well, I want to just explain to everyone listening today, this is completely unrehearsed. Dr. Michael Berry's book, which was published in 1993, last year, Doug Hoffman, Dave Mura, Jim Manus, and myself received about $160,000 from the Department of Labor through their OSHA grant. We used Dr. Michael Berry's book, Cleaning for Health, as the fundamental curriculum, the basis for developing a Clean for Health curriculum that we in 2023, we delivered 54 workshops throughout the country being funded by the Department of Labor through OSHA. We trained over 850 people, and 95% of our attendees told us they had received no training in the last 5 years.
Wow.
92% of the people that we trained in those 54 workshops using Dr. Michael Berry's book, Cleaning for Health, said, I know the name of the cleaning product that I use, but I can't tell you the ingredient. And so the most common answer was, I guess, oh, maybe it has water in it. That's great, guys, but that's not the solvent. That's not the active ingredient. That's not what makes it a clean product. So what we learned last year, there's Doug Hoffman, Jim Manus, Dave Moore, and myself learned last year, this significant gap in our education, training, and knowledge, our skills, in the fact that you know the name of the cleaning product and the disinfectant, but you can't tell us what the ingredient is. And we want to fix that. And so we have then taken the cleaning for health philosophy. I really want to honor and just pay so much. It's just a privilege that I've met Dr. Michael Berry and his vision back in 1993. That's over 31 years ago. We have now taken that cleaning for health approach, and we have developed now at least, I think we've got 4 workshops in the program. And we've actually taken those workshops and we've translated them into 8 languages. And again, you've got to focus on the fact that adults learn by doing. And that's what our cleaning for health philosophy is.
It's up here on my shelf somewhere, but I couldn't find it in a quick scan. But Cliff, let me turn it over to you.
Okay, I guess a response to the question in terms of learn by doing, how do you incorporate this learn by doing into the workshop?
This is so important. Well, again, if you look at a cleaning cart in an airport, a convention center, a hotel, a government building, office buildings, schools, for example, and go through the tools, the equipment, the products, and the chemistry of those products, and just show how fascinating it is when you start to show that the cleaning professional is actually doing their job based on evidence and science. And we do a lot of testing. We do a lot of pre-testing and post-testing. So you'll see me run around with a UV light as I look for both dirt that fluoresces and other contaminants that fluoresce. You'll see me use ATP meters, both for pre-cleaning and post-cleaning assessments. I'm now using a lot of UV LED light devices, Optisolve Pathfinder system, as well as the Bactiscan system, which again uses a combination of UV lights to fluoresce bacteria on a surface. So we've seen this technology come from the food industry, the dairy industry for cleaning the milk pipes, the milk cups for milking, how important that is for controls of infection and infectious diseases. And we're now translating and moving that technology into the front line of cleaning for health in any indoor space.
I have a background in pest control, and we used to use UV lights for rodent detection as well, and urine detection in washrooms and so on. So
this is so about 10, 12 years ago, when I did a lot of work for the US government on biological weapons, and I was running around Afghanistan and Iraq. The PCR machine that I took to the field was the size of a very large suitcase, big black suitcase. And I would run out to the field and I would be able to do real-time PCR analysis testing on samples in many different countries looking for biological weapons. Well, I can tell you now, in 2024, that technology is the size of a cell phone. Same technology. We've gone from a very large suitcase, which I was so excited to have, because when I signed off for it, before I went on an overseas trip, it was like signing out a hand grenade. It was that important. It was that special. So I'd take my big, large black suitcase. Now I've got a real-time PCR machine the size of a cell phone that does real-time analysis. So I don't have to wait days for the lab to give me a result. I can identify whether I have a virus or bacteria or fungi when I'm dealing in any indoor space. So that technology is there. The costs are coming down, but the training, the education, the awareness is so critical that's needed in our industry. But wait for big, exciting things. The number of shows that I've been to this year, and they've had a special section on innovation, has been fascinating.
Very interesting. Steve, let's talk a little bit about spraying things. People spray with all kinds of different sprayers. You got the little pump-up sprayers, your airless sprayers, etc. Your specialty is electrostatic spraying. Can you tell us a little bit about what that is?
Well, the electrostatic spraying is just simply a process that's designed to improve spray coverage and the amount of spray that comes out of the nozzle and ends up on the target. And so with electrostatic spraying, our goal is to improve mass transfer. That's the amount of spray that ends up where we want it to go, but also spray coverage. You know, we want it to go into hidden areas. We don't necessarily want it to cover just the obvious type, you know, surfaces. We want to get good coverage. So electrostatic spraying, it's the science of putting a spray charge on a droplet to cause it to move towards the target. You know, spraying is a very inefficient process, whether it's a spray aerosol spray can or a pump up sprayer or a trigger sprayer or a fogger. These types of sprayers are very inefficient. And that's one of the reasons I got involved in electrostatic spraying, because I did studies on inefficiencies of spraying. And I realized that it's really hard to hit the target that you're trying to hit if you just spray. You have to deal with gravity. If the droplets are too small, they just fall out. Air currents carry the spray away. There's a thing called boundary layer that I studied. If you ever seen a car in a wind tunnel, you'll know what I'm talking about. The smoke actually is blown at the car, but it doesn't hit the car. It goes over the top because there's a static air layer at the surface. And sprays behave the same way. You spray something and yet you don't hit it. So with electrostatics, you add a charge to the droplets, and that electric charge forms an attraction force to the target, so it can, you know, really aid in trying to get the spray where you want it to go. And so, you know, you ever tumble dry clothes in the dryer, and you pull out a shirt and you pull out a sock, and you know they stick together, and then you pull them apart and you can feel that force. You know, it's the old rub a balloon on your head on a dry day. You get charges on the balloon and you can stick it to the wall. These are the things this is the science that we're applying to spray droplets. If you put enough charge on a spray droplet, you can make it move towards the target and overcome gravity and overcome air currents and overcome boundary layer. And in disinfecting, that's important because we want to cover hidden areas. We want to cover not the obvious areas, but we want to cover other areas where pathogens will likely hide. So that's kind of electrostatic spraying in a nutshell.
All right,
There's
Cliff.
lots of ways to do it, though, and I want to get into that a little bit.
Okay.
Well, yeah, well, you know, kind of let's get into that. You know, we previously mentioned the fact that, you know, we had COVID and all of a sudden everyone wants to spray something. And then all of a sudden you see all this advertising and you don't know what to believe. You don't know what not to believe and so on and so forth. And I think the difference is you study this, you went to college, you were interested in it. I would say probably obsessed with it, you know, might be a more accurate, you know, term of your involvement, but yeah, let's talk about it.
Well, I mean, first of all, electrostatic spraying is not new. It's been around a long time. You know, it's been around at least in a concept and demonstration form since Ben Franklin days. You had people out there doing demonstrations of charging spray droplets and causing them to attract targets back in the 1700s. There's lots of different ways to charge spray, and you have to choose the right method for the application. That's the key. So if you're just simply charging powder for painting or oil-based paints, that's a different process than what you would use for spraying electrostatically, say, a disinfectant, which is extremely electrically conductive. So there's lots of different ways to charge spray. So you want to avoid lumping electrostatic sprayers all into one. And unfortunately, during COVID, there was a time very early, like March 2020, when I counted over 19 different models of electrostatic sprayers jumping onto the marketplace, where they were making claims about enhanced disinfection, electrostatic wraparound, 360-degree coverage. I even saw a video on YouTube where a guy was spraying the front of a refrigerator with what he called an electrostatic sprayer. And he said, look, that's all you have to do, and it's coating the backside. And I, know, and hopefully the consumer is educated enough to know that that guy's not telling the truth, because you have to put the spray where you want it in order, at least in the vicinity. And so what I started to do was dig into these electrostatic devices that were coming out on the market. And I found out that almost all of them were using a technology called contact charging, which is absolutely inappropriate for disinfectants, because disinfectants are electrically conductive. But there's other factors too. You need some propulsion to carry the spray to the target that you're trying to hit, because what you depend on is carrying the charged droplets near the target zone. So at ByoPlanet, we know this. I mean, we make electrostatic sprayers and we've been doing it for a long time. The disappointing thing was seeing all these electrostatic sprayers come onto the market using claims about electrostatics that really weren't true. And so, while electrostatics isn't new, the consumer needs to be aware that electrostatics that are used in, say, painting, which has been around since the 40s, and it's very effective, isn't the same technology you would use for liquids that are conductive, such as disinfectants. And so you have to pick the right equipment. And that's a lot of what the training that Gavin talks about and the ISSA talk about is you got to pick the right equipment for the right job. You got to pick the right chemistry, and you got to have training. So that's a mantra. You'll hear that from me many times, because during COVID, what I learned is people just forgot how to be logical. And then they just started buying whatever a salesman might say worked. Well, the University of Georgia, I'm very fortunate to have ties with the University of Georgia Applied Electrostatics Lab, which is here in Athens, because they have a spray deposition analysis lab. So you can spray targets, various targets, and collect the spray and determine exactly how much spray ended up where you intended it to go. So we evaluated all 19 of these sprayers that came out on the market. And the only technology that we're able to see worked was a technology called air-assisted or air-atomizing induction charging. We refer to that as AAIC. That's a type of charging technology that provides an adequate spray charge on the droplet, the right droplet size, the right propulsion, all the engineering things you need to do a good job disinfecting. And it turned out it was the only technology that actually produced an electrostatic result. The other ones, no better than a trigger sprayer. And it took a long time for us to start educating the public, and we're a little too late, maybe because COVID, was there and people were buying their equipment. So I can talk a lot about that, but our job at ByoPlanet is to design the correct equipment for the correct application and then train people on it. And so that's what I'm focused on. So does that answer your question, Cliff, about?
Oh yeah, no, it does. And I think what happens is that, the one thing we really haven't talked about yet is, COVID happened, and it was a great financial opportunity for a lot of people. And I think a lot of people that bought those sprayers got this idea of going into business. I mean, they didn't even have a vehicle. They didn't have a company,
Right.
They go on Amazon, they buy the sprayer, they get some juice, and they believe all these claims, and they're out there even in increasing the amount of claims. When we were a kid, they used to play that game at parties, post office. You whisper something in someone's ear, and then they repeat it and repeat it and repeat it. And by the time it comes back around, it's nowhere near what it was originally. I think the same thing happens with the advertising, and I think it happened with contractors. It happened with people that wanted to get into business. I think it happened with chemical manufacturers. It happened with equipment manufacturers. And the bottom line is, it's all about the facts. And I think it goes back to Dr. Barry's book, and the facts are there, the truth is there, the importance of training, the importance of having a system and having compatibility between the worker knows what he's doing, he's been trained, he has the proper equipment, he has the proper chemistry, and so on. So
all that, it's all that. Electrostatic spraying, though, is quite amazing when it's done right. In our spray deposition analysis lab and the work we do at the University of Georgia, we typically see like 5 to 15-fold increases in spray deposition using electrostatics, say comparing a charge off and a charge on situation. So you can have a great sprayer with the right droplet size and all that. You turn that electrostatic charge on, 5 to 15-fold increase in deposition benefit is something that we're seeing pretty routinely now. And that is amazing. And it's a good system then, because of those increases, it's a good system for disinfecting, pathogen control in human health, animal health, mildew control, odor control, things like that, because you need to put the chemistry in the right place in order for it to work. And when we do these studies, like for instance, if you go back a couple of years, a little history, you know, I mentioned electrostatic spraying for paint, but electrostatic spraying is used a lot in agriculture for pest control. If you like, Cliff mentioned, or I think it was Cliff that mentioned he was working in pest control, but in agricultural pest control, you have a tractor driving across a field at 6 miles an hour, and it's trying to apply a pesticide underneath the leaf where an insect or a disease might be hiding. It's a very difficult thing. So they just use very high toxic pesticides. They use as much as they can, high volumes of water just to kill these pests. But with electrostatic sprays, you can routinely cut the pesticide in half. You can routinely reduce the type of toxicity chemicals that you use. But and so I've seen what happens, because really what you're trying to do is hit hidden areas. So you put more on, but that's great, but you really need to hit the hidden areas. And so I've seen since the 90s good work in ornamental crops, for greenhouse crops, vegetable crops, tree crops. These industries are using electrostatics routinely. And so in the disinfecting world, you know, I wanted to give some degree of comfort that electrostatics isn't new. It's been used in a long time, but there was some challenges with disinfectants because they were electrically conductive, much more so than anything else encountered. And so you have to have a special electrostatic sprayer that's designed to handle those kinds of liquids, because almost all disinfectants that we encounter, except for some very specialty types, are water-based disinfectants that have high conductivity. They're salty. And because of that, you have to know what you're doing when you design an electrostatic sprayer.
Gavin, I'm curious, going back to your experience with the U.S. government over in Iraq and Afghanistan, were they using sprayers, or were they using the right kind of sprayer for in your experience?
Yeah, dealing with the high, and I call these high consequence pathogens, the high consequence diseases that that was my career, and until very recently when I really joined the ISSA and became more involved in the science and the evidence of the clean industry. So I did a lot of work on high consequence diseases, did a lot of work in biological weapons. Spraying has always been part of the work that I do. What's really interesting, though, from when you're dealing with a high consequence situation with a high consequence pathogen, and I'll give it Ebola, for example. I had 3 trips back in 2014 setting up and establishing Ebola hospitals in West Africa. Now, I can tell you now, because we're scared and we're frightened, and we know how 60% of the people were dying that got sick from Ebola. When we disinfect, we don't just wet or visibly wet, we wet thoroughly. And we're wearing the appropriate PPE. Now, that's not based on science. That's based on human behavior. I'm dealing with Ebola. The whole hospital is going to be just drenched, so I know there's no virus left. But again, what we've got here now is electrostatic spraying technology, which is a great example of an established technology, as Steve has highlighted, with a new application in surface disinfection. And the challenge we have in our industry is everyone's gone, history? What history? No, guys, it's gone. What industry? What other industries? And so it's really important that within our clean industry, I'm using that huge umbrella for remediation, restoration, crime scene trauma, hospital operating rooms, airports, stadiums. I do a lot of work with the NFL teams and the NBA teams, and I know what we spray in the locker rooms and on the gym equipment. So really important that we keep this to be science evidence based. And we take that approach that electrostatic spray technology is just more than a device, it's a system. But we don't wait for full government regulation. And this is where both the cleaning industry and their stakeholders have to form a partnership, a team approach to take the manufacturing testing that Steve has done all his life and is so good at and has shown us the manufacturing testing results, and take them to the real world testing, the actual on site. And so my experience working with biological weapons and high consequence diseases was that what we did, we probably overdid, It worked because I did measure whether it worked, whether I did, eliminate the bacteria, eliminate the virus. But in the real world setting, we've got to focus now of moving more to real world testing. And that's a challenge we have because it requires funding, time and resources. And it's really important that we do that. We really focus on that evidence. And I was in a meeting this week with the government, and they said, that's great, Gavin, we love that approach, but we want you to publish the results, what they say, in reputable peer-reviewed journals. And I went, that's not my industry. Oh, well, then we want you to put them here. I went, none of my workers in my industry can pay the money and get those peer-reviewed journal articles. They can't access them once they're published. And they said, well, we won't accept trade association articles. I went, well, you should, because we have a peer-reviewed system in our trade association. We don't just, in our 3 magazines at ISSA, everything that we put in is reviewed by editors and scientists. And it's that challenge we have at the moment of communicating that this is a great example of an established technology.
I've been, in some ways, we have some parallels. I have both with Steve and with you. And, what Steve was talking about is, how they needed to spray underneath the droplets and concentrated pesticides and so on and so forth. And, for instance, aerial spraying initially, and then they came out with ULV spraying, and they were able to use less insecticide and get it to hit the plants and very, very effective. And then I think what happened was that technology went into the industry, and I think it helped from an odor removal standpoint, from an airborne sanitizing standpoint. And this is the next, I didn't realize that this is the next evolutionary step above ULV application. Never really thought about it till Steve brought it up. In your
Cliff, it is, I wouldn't call it ULV, but I would call it LV. It's definitely a low volume technology because you don't need as much.
Right.
But you're just simply adding a charge to it, and a sufficiently high electrostatic charge, it's amazing that it'll coat so well.
Going back to the Gavin situation, I think one of the issues is, COVID came out, and I think everyone looked to the government, tell us what will kill COVID. And, I think a lot of people consider COVID and Ebola or COVID and tuberculosis the same thing. And some of these other organisms are much, much more difficult, to kill, such as C. diff or whatever, compared to COVID. And you have to wait for the government, to kind of approve it. And I think that causes a delay and I think that's where I think you do need a combination of industry and, manufacturers to get together and explain to the government, look, this is an envelope virus or a non-envelope virus, and other types of disinfectants have been shown to, and that's, finally what the EPA ended up doing is, approving products that, would kill similar organisms. But it takes them a long time, to react. And I think a lot of times people are afraid. And, legally, I think you have limitations on what you're allowed to say, correct? I mean, you can't just say, well, you can't just wink at them and say, it's taken care of. I think in certain situations, the public wants proof, and in certain situations, they look to the EPA, for that proof, to have claims on the product. It takes time, it takes money. I remember back, when we had the AIDS crisis, and the first product that was approved, for, disinfecting and dealing with that virus. And the only reason we had that product was the company it was a testing laboratory, actually. And they got the monkeys to be able to use these monkeys in order to do that testing, to get a product approval. And, it was expensive. Took time. Yeah.
Hey guys, I got to jump in here. We got to thank our sponsors. We're going to go to halftime. We'll be right back with Stephen Cooper and Gavin Macgregor-Skinner. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org. The Environmental Information Association, EIA's multidisciplinary membership collects, generates, and disseminates information concerning environmental and occupational health hazards in the built environment at EIA-USA.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. The Restoration Industry Association, the oldest and largest nonprofit professional trade association dedicated to providing leadership and promoting best practices through advocacy, standards, and professional qualifications for the restoration industry at restorationindustry.org. Actionable insights, no more mistakes, no more missed line items in your Xactimate estimates at getinsights.org. Industry sponsors are Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. ByoPlanet at byoplanet.com, improving human, animal, and environmental health with electrostatic spray technology and advanced chemistries at byoplanet.com. Actionable insights at getinsights.org. All right, Cliff, let me go back to you. This is your baby here.
Thanks. I think one of the things that happened is, going back to this whole COVID response, and a lot of facilities were panicked. A lot of facilities, hired restoration companies or cleaning contractors to go in and make an application, to the entire facility. And I think at some point it kind of came down more to reason, where high touch surfaces are more important, and where to look, and so on and so forth. And the one thing that always bothered me is, regardless of how thorough the disinfection was, it's only for a short period of time. It can only last for seconds or minutes or hours, and that was one of the reasons that I kind of looked at your chemistry, and I kind of liked the coating product that you had, this biostatic product, because for a little bit more money, you can have a second application made that's really going to give you something that is going to be effective on different types of bacteria, effective on different types of fungi, and so on and so forth. So I kind of really like that two-step approach. Gavin, is that one of the things that you're teaching, in the classes, or that you advocate, or not?
Yeah, the technology there is so exciting, Cliff, that's coming out. I do a lot of work with airlines. I've been out and I've visited the Boeing research facility out in Seattle, Washington. And again, we talk about armrests and tray tables on aircraft all the time. We talk about those, not just the fact that the infection transmission is real when we touch a surface that has germs on it, bacteria, fungi, or viruses, and then we put our hands to our face and we touch our holes. And those holes are eyes, nose, and mouth. But what we're seeing now, the different surfaces, we can infuse them with copper and other metals to make it more, make that environmental surface, especially hard surfaces, hostile to bacteria, virus, fungi survival. And that's the key. So if we as an industry focus on the fact that in the indoor space, any indoor built space, the built environment, there are reservoirs for germs. And those reservoirs for germs can lead to a risk for transmission and infection. Indoor spaces are complex. They're not flat. The challenge we had with COVID is, what's the largest surface in any indoor space in a room? The floor. How many government guidelines did you see discuss how to clean the floor for infection prevention and control? How many peer-reviewed journal articles are there out there? A lot. We talk about the floors all the time in nursing homes, in hotels, in convention centers, in airports, and in hospitals. The floors do play a role. So the challenge we have here right now is time is our biggest enemy. And what the electrostatic spraying technology has helped us with is a delivery system for a disinfectant that we know works and saves us time. So let's for example, you've got a 18,000 square, you've got a sprayer that can cover up to 18,000 square feet per hour. You've got probably 30-minute of continuous spray time with the disinfectant. The disinfectant chemistry is a contact time of maybe 2 minutes. How much time does that save you? If you want to go back to what the federal government through CDC was saying, oh, just use a handheld spray bottle? No. When I work with professional football teams, the NFL teams, Philadelphia Eagles, Miami Dolphins, Dallas Cowboys, or I work with NBA teams, I look at the locker rooms, I look at the gym equipment. They, at the very start of the pandemic, were using wipes as specified by the government, the federal government, to wipe down all of their gym equipment, to wipe down the locker rooms. Man hours, that's 24 man hours, or person hours, I've got to be correct, person hours to clean those facilities. You need to bring in electrostatic sprayers to do that. And the challenge we had was, as Steve said, it was exciting. I totally support the innovation and the movement of our industry to use evidence-based and science-based and established technologies. But the fact was, there were so many different products coming out there that, again, of varying quality and efficacy. And so the challenge we have is the federal government through the EPA looks at the disinfectants and says, yes, use these disinfectants because we've done our due diligence. We have the data, the results to support these disinfectants that will kill or inactivate the germs. But then the actual device, the delivery device, which is the sprayer, was not. And I just wanted to pull up a interesting clip. I was just looking at the CDC website, and they've just updated their website on February 8th of 2024. Safety precautions when using electrostatic sprayers, foggers, misters, vaporizers for surface disinfection, all on one page, all these different technologies on one page. And then they said, only use them by trained professionals. And then they've made this statement, and this is classic. CDC does not either recommend or not recommend use of these devices for disinfecting community spaces. Which side of the fence you sitting on?
Right.
That's painful.
That's a good one. While we're talking about products, Steve, what types of products can be applied and what types of products should not be applied using these electrostatic sprayers?
Well, I mean, go back to the functionality. Will it charge? So, the most disinfectants are water-based, and as I said before, are highly conductive. So we designed equipment for that. So what won't work in our equipment, if it was like a thick oil or something like that, but we don't run across that commonly in our industry. However, if you were to choose another type of electrostatic sprayer or something that's calling it electrostatic sprayer, I would say that none of those water-based, highly conductive disinfectants would work at all, because they basically short out the system on those types of contact charging devices. So if you're talking about induction charging with air-atomizing, it's a wide range. Almost everything out there's worked. Of course, we always test, and we always encourage people to use the safest and lowest toxicity type disinfectants, because you have a choice, and you should look for. You have to know your pathogen. You have to know what you're doing. You also have to know your target. Gavin mentioned these are complex targets. I mean, imagine a locker room for the NFL. It has got so much surface area in that very complex environment, a spraying environment. So you want to make sure that the system that you choose is able to cover, and relatively quickly, these complex types of areas. So we use air propulsion to deliver the spray, to give us some turbulence and to get those charged droplets around and through complex geometry. So the chemistry matters, again, the equipment matters, the way it works matters, the target matters. But I would encourage anybody who has a question about chemistry to reach out. But we will test something we don't know. I mean, recently we're being very involved in the animal health industry. There has been a lot of issues that have come up in areas like doggy daycare, pet hosting facilities, any place like animal shelters, where you have animals are social and they're coming from all different places. You know you're going to have spread of pathogens. And so there's a big concern now of doing the right job with the right chemistry and the right devices in these places. And so we're working in those kind of industries as well, just to, so recently I've been testing quite a few of the chemistries available for animal health, but we have some chemistries that we have a long, long history with. I'll give you some examples. HOCl is a very safe, low residue, leaves no toxic residues, and it's a very effective for a wide range of pathogens. So we have a lot of experience with that. We have a lot of experience with quaternary ammoniums, like and also quats with chlorine dioxide, like vinyl oxide in the cruise industry. Long history with that. I mean, you remember what was going on years ago in the cruise industry. Norovirus outbreaks were actually preventing boats from landing into port because there were so many people that were ill. And so once those critical events happened, you have to do exactly what Gavin says. You have to look at the situation and how do you eliminate the risk. It's not just spraying something, it's actually how you spray, when you spray. And they developed some very good quarantine protocols and things like that. But one of the key chemistries that was used on the cruise ships to help was vinyl oxide, which is one we have a very long history with. And one of the others that I'll mention is Armatrex, which you guys talked about a little bit, but I'm going to throw out the brand name because that is a silent quat that has characteristics that give it pathogen control on surfaces for like 30 to 90 days, which is a big breakthrough. And so a good clean surface that's already disinfected, a secondary application of something like this Armatrex is a game changer for the health industry. And right now we're doing a lot of work in the animal health industry using this treatment because you can't spray every time you need to. You can't. And you know, pathogens spread. But another thing I'm learning is about, and I know you guys are mostly indoor air quality conversations, and I'm doing the best I can to educate myself on indoor air quality because I know from a lot of my past research that electrostatic sprays, when they're properly charged, can remove particulates from the air. And I know that pathogens move with particulates in the air. So a lot of the work we're doing now is to use electrostatic sprays after a surface disinfection in a room to also spray into the air. And we're seeing some pretty fantastic results for removing pathogens and removing particulates that pathogens can hitchhike on in the air. So there's more than just surface contamination. I mean, surface pathogen control that we're talking about here. It's also air quality. And air quality for spraying, you can actually have a kind of a spray system that if it doesn't work well, it can actually cause air quality problems. Spraying can cause air quality problems. Casting spray into the air with a fogger, for instance, or with an uncharged low volume or ULV type sprayer, those spray particles linger a long time, hours. We're doing air quality analysis after sprays, and we have found that with electrostatic sprays, if it's properly charged, can reduce that lingering aerosol time 20 to 50 fold. In other words, they make the spray and the particulates that are in the air move quickly out of the environment, which I think is another great aspect of electrostatic spraying if the droplets are properly sized and properly charged.
Cliff, do you have one? I've got another one for Gavin, but and we also need to go to the roundup in a moment. But if you want to get in here real quick, that's fine.
Okay. One of the things that that you were involved with, I guess, a similar technology is dealing with cooling of athletes as well.
Yeah.
And I suspect in those situations, again, you may be spraying water. Whenever you're spraying water on an athlete or maybe inside of a building, do you add anything to it to amend it, like a surfactant or anything to, try to change surface tension or get penetration through surface tension? Is that necessary or not?
Well, for cooling, no. I mean, it's pretty well known that if you cool the skin, the largest organ on the body, then you can bring the athletes or whoever's temperature down. I mean, we were motivated years ago by hearing about high school and professional athletes getting heat stroke, and some of these resulted in death. Also, I'm motivated by hearing stories about UPS drivers in Dallas, Texas last year in that heat wave, really struggling to do their job. And a couple of them, were in bad shape, and it wasn't just UPS. It was any industry that you have that kind of heat. So I know that with spray technology, and again, it's a little different technology. If you expand a gas and add a little bit of liquid to it, it'll cool. I mean, that's how refrigerators work, right? That's Einstein's very first invention was, coming up with expansion cooling, or working with concepts that are already out there, like the Joule-Thomson effect, and making a cooling device. So we took that idea and we applied it to a sprayer to deliver a small amount of liquid. Water is all you need, and expand the gas and cool the skin. And the results are amazing. And so it would be great. That's new. It's pretty new. Quite a few college football teams have now adapted it, and with really good feedback. Some of them truly believe that it gives them the competitive edge, which is what they're looking for. Right. But our motivation is the athlete's health. And interestingly enough, now it's a little bit in the equine industry, because horses are athletes, and so they need to be cooled. So that work has been done. We do a lot of research before we talk about our products, and we do a lot of testing in the marketplace before we talk too much about our products. But we have launched the product called Be Cool, which even yesterday I was testing it with package delivery drivers, who people think that's a very hot job. Well, wait till you get into the back of that truck. It was only 85 degrees here yesterday in Athens, Georgia. In the back of that truck, I couldn't load 10 packages without taking a break. The driver told me there's no way that I would last in this business. And I don't think I would. But we put the Be Cool in there, and you know what? It was fun. It was pleasant, and it was cold. So it's going to be a game changer. But that's a different industry. We're always looking at different industries to use our technologies at ByoPlanet. But one of the most successful for us has been the disinfecting, because the science is showing well and the results are showing well.
Let's go to the roundup, Grayson. All right, the roundup today is brought to us by ByoPlanet at ByoPlanet.com, improving human, animal, and environmental health with electrostatic spray technology and advanced chemistries. All right, I got to find Cliff. Let me let you go first, and then I have one for Gavin before we sign off here.
Go ahead, Joe.
All right, Gavin. Yes, earlier in the week we were talking, and it really kind of struck me when Cliff talked about the fact that typically in the restoration world, in my small amount of time there, they've taught that you first have to clean a surface before you disinfect the surface. And you kind of had a little different take on that. And I was wondering if you could maybe tell our listeners a little bit more on your thoughts on that.
Oh, no, that is still important. That we can't disinfect dirty surfaces. But the challenge we have is that both, a lot of the guidance that was out there was visible dirt. Now, dirt is both invisible and invisible. And the only way we can detect both dirt, contaminants, pollutants, germs on surfaces is by doing testing. Again, we have testing for technology, equipment, ATP meters, again, should be used throughout the industry on a routine daily basis. So that's my opinion. So where we're moving this right now, ISSA has a program called Making Safer Choices. And that Making Safer Choices program is funded by the federal government through EPA. We're doing this in partnership with the Penn State College of Medicine, as well as the City University, New York School of Medicine. But we're forming partnerships between universities, trade association, ISSA, and with the clean industry and stakeholders. And what we want to do is create these partnerships to generate real world evidence to support, sprayer technology like electrostatic sprayers, But more importantly, I went to the government and I showed them the budget for the next 2 years. It's about $1.2 million in this Making Safer Choice program. And they said, you're going to develop toolkits. And they thought I was going to go to Walmart and buy a little plastic container. And I went, no, my toolkits are the size of shipping containers. We're going to put shipping containers out there for airports, schools, hotels, office buildings, churches, you name it. And we're going to give them that holistic, comprehensive solution. This is how you clean for health, as we mentioned right at the beginning, based on Dr. Michael Berry's philosophy, how we clean for health, but we do it based on evidence. There it is. Yep.
I got it. That's a good one there.
31-year-old book that is so important for what we do today. And then we're going to, through evidence, provide shipping containers to facility managers of buildings to ensure they clean for health. And we're going to use the best technology, the best equipment, and help people understand the chemistry of the cleaning products and the disinfectants we use.
Cliff?
I'm good, Joe. Why don't we bring Adrian in?
All right. Sounds like a great idea. Adrian Foley.
And Adrian, tell me, you were talking about a different application that fire damage restoration contractors were doing with the system. Why don't you tell the audience about that?
Thanks. Great question, Cliff. So they're not doing the whole job out of the gate, but when they're going in and doing the estimate, just kind of walking the job right out at the very first start, they are using electrostatic sprayers, our HOCl chemistry, and spraying down, just that first room, let's say, to give an example of how fast it knocks down the odor. And they're really using that tool to win jobs, which was pretty exciting when we found this out, because we were thinking they were, using the tool during the jobs, which they are, but we had never thought it would be something, an electrostatic sprayer and our chemistry be something that would help them win more business. So that was pretty cool.
I got a question for you, Adrian. I think this is an important one. When building the reason Steve, I think, got so involved in ByoPlanet was when the University of Georgia bought a bunch of electrostatic sprayers that their own laboratory probably would not have recommended if they would have known in advance to ask their own laboratory. But I'm wondering if there's a cost proponent to this where you look at it and you go, okay, I know if I'm buying a sprayer, a supposed electrostatic sprayer that's $59.99, I know I'm not getting what I should be getting. What should I expect to pay? What should a facility manager expect to pay for a good quality electrostatic sprayer?
Well, quite a bit more than $59.99. I'll tell you that. I mean, if you see something, there's a lot on there for $30. You might as well just take $30 and throw it in the garbage, because it's the same.
Yeah,
thing.
but you're throwing it. The problem is you're throwing a lot more than $30 away, because you have to consider the cost of the labor and the chemistry, because the sprayer ends up being pretty low cost compared to the chemistries that you're putting through it over time, and also the labor that you're investing into getting a good result. Now, you can go out there and get a bad result, which is not what you want. So you get good equipment, you get the right chemistry, and you get the right training, which part of that training is how fast you can really spray. It totally depends on the complexity of the target, the pathogen you're trying to control, the seriousness of the issue. Critical pathogens are approached differently than a routine treatment of a kennel in a doggy daycare. So you make decisions, but I can tell you, the equipment always ends up being the lowest cost on the list when you look at the whole thing.
Right.
And so, you buy the equipment because you want to save money on the chemistry and the labor, but the equipment has to do that job to allow you to save money on the chemistry and the labor.
Yeah, exactly. Great. I couldn't have said it better myself. And I'll tell you this, you guys had that.
Well, that's coming from people talking to me, customers who use our equipment. I say, why'd you buy it? And they tell me, they say, because it works and I save money on chemistry and I save money on labor. But at the same time, the highest thing that has to happen is it has to work.
Right.
You have to get the job done. The pathogen control has to be effective.
And Adrian, did you want to add something? I mean, am I looking at $1,000? Am I looking at $10,000?
No, less than that, 500 to 700.
Okay.
And it's coming down every year. I mean, but you have to also look at the market. Like the market was flooded during COVID with all of this cheap plastic crap that wasn't even real electrostatics. Everyone's got, I mean, I can't tell you how many customers we have that tell us the same story. They were burned. They bought 100 units. None of it worked. It started leaking all over their boots as they were spraying. I mean, it was ridiculous. And that kind of blew up the market for a while. And now we're starting to see a slight change as people are coming back to the real technology that actually does work. Yeah, it's definitely more expensive, but like Steve said, it's far more valuable. It's a single transactional purchase, but then that lasts 3, 4, 5 years, and you're getting exactly what you had hoped the other, crappy products were. And by the way, those brands are all dropping out. I mean, they're all because
that price point is not a problem for our restoration audience. I'm thinking though some schools and others may have more of an issue. And one more quick question before we got to wrap this up. Gavin, at some point, somewhere along the line, we talked about the coverage and how to evaluate the type of coverage, because that's important with disinfecting. What do you recommend when using a electrostatic sprayer as far as evaluating, am I putting enough of the product on the surface?
Yeah, those surface coverage rates are really important when it comes to infection prevention, infection control. So again, a lot of that data is there, but it's hidden. It's not publicly available. I totally agree with what Adrian and Steve said. Again, I'll go back. This is established technology. It requires training. We want those people that are trained to be acknowledged that they're trained. We want to give them, the credibility and say that these are well-trained professionals that can use this technology in many different situations. So I think what would really help the industry right now is a cost-benefit analysis approach that's supported by data. All of us on this call, we know the technology well, but now we have to support the sprayer's value. It's not just the cost of the sprayer, it's showing its value over time and how it's used. Do I go into a crime scene and not use an electrostatic sprayer? I take an electrostatic sprayer in every crime scene I go into because I know what the technology does. I know it makes that area safe. I have to decrease the bacterial load. I have to decrease the viral load. And I wear the proper PPE. So let's mature, let's evolve. Let's look at the science. Let's provide the training we need. And let's look at those areas that we can provide. And I think that cost-benefit analysis approach is necessary, and put it into storytelling. Show real-world examples.
Do ambulance services purchase this kind of, it seems if you're worried about going into those areas, if I'm an EMT, I'm really worried about it. I'm the first guy on the scene.
Well, it's interesting that when COVID hit, we had only a limited supply of equipment. So we actually prioritized for medical service, emergency service, because you have patients who are like in a vehicle, they're in an ambulance, and now you have patients removed. Now you need to disinfect every time. So any situation like that became a very important situation, and it had to be done quickly. So ambulance companies were using our electrostatic equipment to disinfect back of ambulances, and that's been proven to be there's been some good studies done because it's a very complex geometry. If you open the back of an ambulance, there's all this stuff in there.
Oh yeah.
And a lot of it's electronics and things like that. So we developed some protocols working with even the ISSA to be able to disinfect the back of emergency medical type vehicles. And so that's a great example of where it should be used and should be used routinely. And also, it's a good example of where you can get the highest benefit because it's quick. For the more complex the geometry, the faster it is compared to wipes and trigger sprays and all those things.
Yeah, and by the way, I want to just jump in and add to that. These folks, these first responders, are now dealing with more than ever before. So we're not just talking about maybe pathogens that are coming off of the bodies as they come. We're talking about fentanyl. They get even close to somebody, and then they're getting sick from the fentanyl, and it's deadly. So it's more important than ever.
And that's really important, Adrian. I've had a couple of instances now in a university dorm room as well as the back of an ambulance. Fentanyl can come in many different ways that they're delivered. We get a little tablet, looks like Skittles, or if you're dealing with the fentanyl powder. And I've had a few instances where we had an ambulance with fentanyl powder that went everywhere. I've had a university dormitory where there was fentanyl powder. And again, I've used an electrostatic spray with the right chemistry to go in there and try to neutralize that fentanyl before we even touched anything. That is a critical part of the process.
Mm-hmm.
Very interesting. Before
Lots
we go,
of applications.
We like to give our guests the last word. Anything you'd like to add? Anything we've missed? I think we could do another hour on this topic. But Steve, let's start with you.
No, I appreciate the time. I just want to encourage people to be educated consumers. I think the most important thing to do is to listen to seminars like this and understand technology, but also understand how it affects what you do and ask questions. ByoPlanet is here for you. We're a company that sells equipment and chemistry, true, but we approach things scientifically. And so if you have a question and we don't know, we're going to go look for that answer. If you have a question and we know, we're going to try to answer it the best we can, but we're here to help the industry.
And Gavin?
Electrostatic spray technology, it's more than a device, it's a system. And let's take a systems approach. Let's form partnerships to do those real world evaluations.
And Adrian?
You'd mentioned price point before. Let's not let the price point scare anybody. Schools and all sorts of other institutions, B2B businesses, we have special programs that can help out with that. So it should never be a barrier to entry for an organization or institution that wants to protect their people and their plants and their animals.
I would imagine the COVID funds can be used on this type of technology.
That's right. That's right. And we have some great programs now where, if you commit to some certain level of chemistry, we'll throw in that sprayer or several sprayers at a really reduced cost that makes it attractive. So,
gentlemen, thank you. This has been fascinating. I always enjoy a good discussion with a good group of people. Our thanks to this week's guests, Steve Cooper, Gavin Macgregor-Skinner, Adrian Foley, my co-host, the Z-Man, Cliff Zlotnick, Grayson, Gone Fishing Fisher at the controls. Great job, Grayson. Most importantly, our growing audience and our sponsors. We'll be back. We're going to take a little time off to let Grayson go beat somebody up in an MMA match next weekend. And then we'll be back in a couple of weeks with the next live edition of IAQ Radio Plus.
Thank you.
For IAQ Radio, I'm Spike Reel saying thanks for listening.